Assalamu alaikum wa rahmatullahi wa barakatuh. Today's lesson about the hyperbola. What it means by the hyperbola. The hyperbola is like two parabolous curves. Like here in this part, in this shadow, the shadow of this lamp contains two parts here, one parabola up and one parabola down. So these two parts, these two curves, called one hyperbola. Hyperbola. What it means by the hyperbola, and what about the ingredients with the hyperbola? The hyperbola contains two curves, one to the right and one to the left, and one transverse axis, one center between them, two vertices, one vertex here, one vertex there, and two foci, one focus here near to the vertex and one focus near to the other vertex. The definition of the hyperbola is the set of points in the plane, the difference of those distance from the two fixed points called foci is constant. Okay, as we learned before, the ellipse, we wanna learn the standard form of the equation of the hyperbola. What is the standard form of the equation of the hyperbola? Let's see here the equation of the hyperbola. The equation of the hyperbola, the standard form is the same equation of ellipse, but in the ellipse we already have A, B as 2 points on the curve, but now AB here on the curve of the hyperbola. Where is A? A here, the vertex of the first curve and the vertex of the second curve. B here and there. But we have C in the focus, and now here is A, here is C, also here is A. So where is C? C is here. Again, C is here. Here is C. The same distance from the transverse axis point center to the focus is this distance. C is here, B here, A here. So C squared is A squared plus B squared. A called vertex, B called covertex, C called focus. Another style, the vertical hyperbola. Here was the horizontal hyperbola. So the vertical hyperbola, A is here. So here is A, here is B, here is C. Here is A, B, C. Also C squared equals A squared plus B squared. So if the hyperbola is horizontal, so A with X. But if the hyperbola is vertical, A with Y. So A location on X-axis in case of horizontal hyperbola, also A in the position on Y-axis in case of vertical hyperbola. For the horizontal hyperbola, X squared with A squared minus, not plus like the ellipse, Y squared over B squared equals 1 if the center is the origin point. Don't forget. But for the vertical hyperbola, the standard equation is Y squared over A squared minus X squared over B squared equals 1. Don't forget that C squared equals A squared plus B squared. If you want to be and you have C and the A, B squared equals C squared minus A squared. Here is an example. Find the vertices and locate the foci for each equation of the following here. Here, if he started by x squared, so this is a horizontal hyperbola. So here is a squared is 16, so a equals maybe 4, maybe negative 4, and b squared equals 9, b equals maybe positive or negative 3, and c squared equals a squared plus b squared, c equals 5. So again, don't forget that c with a horizontally, so we have two vertices. One is 4, 0, horizontal. One is negative 4, 0. Two co-vertices. 1, 0, 3, and 0, negative 3. Again, 0, 3, 0, negative 3 for two co-vertices. And the focus is horizontal. The focus is on x-axis. So we have two foci. One is 5, 0, and one is negative 5 and 0. So we have finished our work. Again, the two vertices are 4, 0 and negative 5, 0. I'm so sorry, 4, 0 and negative 4, 0. The foci, one is 5, 0 and negative 5, 0. Here is the co-vertex B. B here is 3, 0, and 1B there is negative 3, 0 for the first equation. The second equation, I think it's like vertical. Here is, yes, A forever with the first term before the subtraction operation. So A is 3. So we have two vertices in the vertical position, not in the horizontal position. The first vertex is 0, 3, 0, negative 3. Also, we have two co-vertices horizontally, 4, 0 and negative 4, 0. Don't forget that C is 5, also because it's the same 9 and 16. But don't forget the two foci on y-axis. So we have one focus 0, 5 and one focus 0, negative 5. Again, here the style of the second hyperbola graph. Two vertices 3, 0 and negative 3, 0. No, thank you very much. 0, 3 and 0, negative 3. Two foci 0, 5 and negative 0, negative 5. Two co-vertex. One here is 4, 0 and one there is negative 4, 0. Okay, another example on the same part. If you have here two foci and two vertices, can we write the equation, the standard equation of the hyperbola? Yes, for sure. Here is vice versa. The previous example, I gave you the equation and I asked for the ingredients, A, B, and C. But here I give you the ingredients, the foci, C, the vertices, A, and you're gonna find B and then write the equation. The first here observation, 0, blah, 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 0, blah, blah, blah. So A and C on y-axis, So this equation or this hyperbola graph is a vertical graph. We can graph it and write the equation in no time. Don't forget, this is the standard equation forever for any vertical hyperbola. I'm going to start by y instead of x, and don't forget the subtraction operation between. Now we have A. Here is the word foci. Here is the word vertex. So A is the vertex, 2 units. 2 units, absolute distance, 2 units. C equals 3 units. But B equals, yes, B squared is C squared minus A squared. So B equals radical 5. Radical 5. So don't forget, the equation here becomes y squared over A squared. Don't forget A was 2. Minus x squared over b squared. Don't forget b was radical 5. And now the